Alright, so this is the lecture makeup for missing on last Wednesday, which was October 14th for both MA80 classes for the spring semester or autumn semester for 2020. So let's just write that out really quick here. Sections 305 and 304 making up for Wednesday, October 12th or 14th. So last time we were supposed to finish up the chapter on percentages. So that's what we're on right now. And we first talked about conversion first. So if you remember, there's 6 different types of conversions that we have to remember, and you have to be able to reproduce common exam and especially the final exam. And let me write those out really quick again. You have percentage to fraction, percentage to decimal, decimal to fraction, decimal to percentage. So you can see it's a combination of all 3 of the things. That leaves us with fraction to percentage and fraction to decimal. So these were all demonstrated on last week's lecture, last Monday. Demonstrated on October 12th lecture. And the other thing we learned was we talked about percentage problems in terms of word problems. Where you had to translate and solve. Translate and solve. And you could do it the traditional way where we were talking about, where you set up the symbols to be equivalent to the representations of mathematical. So remember, if you see is equal to, or is an equal sign. If you saw of, remember that's a multiplication sign. But I was telling you that I prematurely, which we have to do it later in this chapter, was I introduced what's called a proportion. So the proportion, remember, proportion was the whole A over B equals C over D, where B and D can't equal to 0 because then it'll be fractions. And then that's how I also translated for you all to understand is over of equals percent over 100. And if you use this proportion every time, remember you'll get the answer correctly. And the other thing to remember is that the percentage, whatever it is, when it goes in the upper right hand corner right there, you don't have to convert to a decimal because the percentage is already over 100, right? To take a percentage divided by 100 is the same thing as moving the decimal place to the left 2 times. So that's what we did last time. Now, what do we have to do to wrap up the rest of this chapter? Well, it turns out that there are more applications. So right here in light blue, I wrote word problems, but those are just more like translations. So word problems is used very loosely here. Now we actually have to do physical word problems where they're talking about some kind of scenario and everything of that nature. And what we're going to show you is I'm going to show you a box that was used. I didn't create it. Former colleague that's still teaching at FIT, actually current colleague, is still teaching, and she taught me this because, well, it was her expertise before I came along. So this is what it looks like. So you can call this the box, if you will. Or the box method. And it looks like this. So you got to draw a long rectangle box and need more space. Give yourself a little bit of space because we're going to write in it. And it has 3 rows and it only goes, there's only 2 columns. So there's my 3 columns, or 3 rows. And here's my 2 columns. And then what you want to write is on, it actually doesn't matter whether you put on the left or right, but I'm going to start with the left side. So money is always one column, percentage is the other. And as I was saying, it doesn't matter whether the money's on the left or the right. It's going to fall into place because this ends up being a proportion. And then you want to label on the left side, old as in old price, change, and the change, whatever it may be, can be a positive or negative change. So I'm going to put that in parentheses right there, positive or negative, and then new as in a new price. So again, this may seem unconventional. I know a lot of you probably have not seen this before because again, it was made up by someone that currently works there, and what happens is that if you follow along with this method, and again, you will be able to replay this video because you can watch it again, then it hopefully will make sense. And if not, as always, we can go over what we need to clear things up. All right, so let's move to the first example right here. So there are, let me count here, 1, 2, 3, 4, 5, 6, 7. 7 topics that we have to go over in terms of the percentages. And we'll see if we can get it all done in this single video because I'll show you an example of each. But the thing is that this box, if you will, can allow or assist you to solve for any of the pieces or the spaces or the holes that you see here because it depends on what is given to you. And again, like I said, some of these questions you may be able to just do it right on your own. However, if you fall back on this box, it will always point you in the correct direction. Okay? So let's start with something simple. And just in case, I'm going to write down the 7 topics that we can use this box for. So, topics. And they're the following. They have to do with percent increase, decrease, increase, decrease. We have to do this for sales tax, but most of you are familiar with that. Commission, which is technically the same thing as adding tip, just a different scenario. Discount, which we all love when we're shopping. Something involving retail specifically is markup. So you're marking up prices. So I'm going to put in parentheses here, retail. Something called simple interest. And all of this is accompanied by the fact that this box allows us to do proportions. So proportions, again, are what I went over last time with the 2 fractions that are equal to each other. And this box will allow you to set a proportion every time with these topics. So I lied, there's 1, 2, 3, 4, 6 topics, but they all involve proportions. Okay, let's start with the first example, something simple. So say we had a percent increase right here. We'll do example 1, and this is a percent increase. So say the question is Yeah, say the example is the fare of, let's say, NYC Metro is currently $2.75. What is the price if the percent, or if the cost rose by, let's say, 20%? So you have 2.75 or $2.75, and then it increases by 20%. What's the new price, right? So that's what they're asking you right here. What is the price? I guess what is the new price? We know it's new, but again, it's just in context to this. So I'm going to use this same box right here. I'm not going to draw it so nice this time. This is just to show you, but now I'm going to just scribble it. So we got the box, the column, and then we have percent and dollar. Okay, so what I was discussing was that you want to write down what you know. And we have now 3 things right now. What also we find out is that when you're using this box, generally you find out that you have 3 out of the 4 things. Now, where did I get 4? Remember, you need 4. We need 4 we need 4, sorry, 4 items for a proportion. Proportion. Right? Remember, it's the whole A over B equals C over D. So we need 4 items. Well, I'm telling you right now, when you do these problems, anything that relates to percentage in terms of increase, decrease, sales tax, all that fun stuff that I listed earlier, you need 4 pieces of information. And the problems always give you 3. So what are the 3 here? Here's 1. Here's the new price. We don't know what it is, but they give you it. And there's 20%. Not only 20%, but rose by 20%. So those are our 3 pieces of information. A dollar amount, some dollar new price, and some percentage, a rise by 20%. And remember, on the left, you would write old, change, and new. And under the change, you want to write plus or minus so it can help dictate which way you go. So I'm going to use the same light blue here. So 275, is that our new or old price? Or even better yet, 275, is that percentage or dollar sign? Hopefully it's dollar sign you see right there. So that means that it goes in the left-hand column here of 275. Okay, now what's the next one? What is the new price? We don't know what the new price is. That's what we're looking for. So again, is a new price involving dollars or percentages? Again, it involves dollars. So it's at the left side, but new price, if we don't know it, we can put a variable x. And then the last one is 20%, right? 20% goes where? Well, is it dollar or percentage? It's on the right side, so it's a percentage. Or since it is a percentage, it's on the right side. But it's not talking about an old, change, or new. It says that it rose by 20%. So that means you don't know what the old is. If you don't know what the new is, you know that it's 20 here. And not only is it 20 here, it's a positive change, right? It's a rise in price. So that's why you have to have that plus sign there. Okay, and then this is what you have. Now remember, the proportion says that you need 4 items. But the problem here is that you see only 3. Well, it turns out actually that you do have 4. You actually have a lot. So the first time going through this box, you're just plugging in numbers. And then the rest you can calculate from information that you see here. So I'm going to scroll just a touch, and I'm going to give you some clues here. So I'll tell you this right now. When you're doing a percent increase or decrease, you always have a base amount. What's the base amount? It's this row right here. So you can think of this as a base amount. And again, this is for increase and decrease. That's what the problem we're in right now, percent increase. Well, if we are a base of 275, that's the original cost. That's 100%. Okay? And then, how do we get the new? Well, the first and the second row, the old and the change, those combine. How do they combine? Well, they combine by adding. That's why we circled that plus sign. So you can think of this as a huge addition sign where the first two rows can add up to the third row or any combination of that, right? You can take the third row, the new row, and subtract the change row and you get the old price. So it just becomes a big addition / subtraction problem. So if you had originally 100% of the cost and it rose by 20%, you now have 120%. So now we have this proportion. And if you might ask, well, how do I see the proportion? If you look at, again, this right here on the right-hand side, let me use a different color. If you see this light green on the left-hand side, it states that we need 4 items. What are our 4 items? We have A, B, C, and D. So you can only use 4 of them if they're in the same row and they have a neighbor as I describe it. So if you look on the left column here, the dollar column, you see that 275 and X are used, and I can only use those because they have a neighbor to the right here of another number. So the 275 has the 100% and the X has 120. Notice that if you looked on the right hand side for the percentage sign, you saw 100% you can use because it has a neighbor of 2.75, but you can't use the 20% because there's no neighbor there. It's unknown, so you can't use this column at all. So if anything, you can cross it out. It was more there to guide you to set up your proportion. And you can see here that on the very last one, you can use the 120 because you have the X there. So what does your proportion look like? It looks like this. You have 2.75 over X equals 100% over 120. And again, it's the same idea that you don't have to convert this to a decimal because the percentages are in proportion, so they stay the way they are with 100 and 120. In fact, if you change them to a decimal and you did it appropriately, it would still work. It's just that you have to move the decimal point. I'm going to just demonstrate really quick. Don't write this down. You have to move the decimal point twice like this, right? So it had to be 1 over 1.2. But 100 over 120 is the same thing as 1 over 1.2. So let me erase those right there. And if you don't believe me, you can do it on your calculator, right? If you do 100 over 120, you get a number. And then if you do 1 over 1.2, you should get the same exact number. So you cross multiply this way. So that's 100x equals, right here, 120 times 2.75, which is 330. And then if you divide both sides by 100, you get x equals 330. 330 what? Well, we were looking for this x right here, which is the new what? The new dollar amount. So this is a dollar answer right here. So the answer will be $3.30. $3.30. So you can see here, you can check your answer too. Aside from plugging back in and seeing if the math works, you just have to check if it makes sense. If you started with 275, your answer, if it went up from 100 to 120%, whatever your x is, it better be more than 275. In this case, you could do a quick check, and it is. 330 is more than 275. All right? So let's do a discount problem or a percentage decrease. Same exact thing, but we talk about a decrease. So let's go example 2 now. Example 2, and we're doing what's now a percent decrease. And say the problem says something such as you buy coat on sale for 80% off. And then you go, original price was $85. What is the new sale price? So again, you do the same thing. Draw your box, 2 columns, 3 rows, dollar on one side, percentage on the other, and then again, help yourself by writing old, change, plus or minus, and then new. But I can already tell you, since we're saying that, hey, let's do a percent decrease, 80% off, you know that this is going to be a subtraction, right? So what will happen is that we're going to have some kind of subtraction or decrease of the problem. So let's use the information that we have here. Again, we have 80% off, original price, what is the new sales price? So again, 80% off goes here. The original price, which was the old price, goes here, $85. And we're looking for the new price here. So again, those are the 3 pieces of information that we have here that we can use preliminary information to fill out the box. Now we can add or subtract. In this case, subtract y again because it's a percent decrease, and you treat this like a big subtraction problem. When I draw this line in light blue right here, the solid line right there, it's just to mimic old problems you used to do when you did, for example, 45 minus 13. Remember, this sign or this line, as an example, is supposed to be an equal sign here. Equal sign. So if you remember from doing problems like this in primary school, that's what it was supposed to represent. So that's what that same line represents there. So if the old price is, again, what it started with, it's 100% of the price. But if we're subtracting 80%, because that's the discount, we're left here with 20%. So remember, the last problem we added, this time we subtracted. And then you can see your neighbors are right here. See how these two are next to each other? So that's part of your proportion, and these two are next to each other, which means we don't use the middle row again. So your proportion becomes 85 over x equals 100 over 20. And again, you don't need to convert those percentages. And then you cross multiply here. So these two, you got 100x equals these two, 85 times 20. Left with 1700. And you divide both sides by 100. You get x equals what? $17. And again, that answer makes sense because if you look at it, if you had originally $85 and then all of a sudden you had an 80% discount or decrease, right? Subtraction here. And whatever your answer is, it better be well less than $85, right? So that takes care of the, what do you call it? the increase and decrease when you're talking strictly about percentages. But what about when you're talking about, say, the next topic, which is sales tax, right? So here's example 3 having to do with sales tax. Now, a lot of you are already familiar with this because of just the fact that you shop, right? So say you go to a restaurant. That's always the easiest one. So you go, you have a bill for dinner of, say, $59.95. And sales tax in NYC is 8.875%. What is the total cost of the bill after taxes? Now again, if you're already familiar on how to do that, that's great. You don't have to use the box method. You can do it however you want, right? And as long as you get the correct answer, that's what matters because you'll see that in a multiple choice exam. However, for those that need a little bit more structure, you can always use this box and it'll work, right? Because I'll show you what I mean. So you got old, got change, plus or minus, and a new pricing right here. So you write down what you know. What do we know? We're looking for a bill of $59.95. We know the sales tax, and they're asking you now the total cost after tax. So as I'm sure everyone knows, tax is an addition problem, right? You add the tax, you don't subtract tax. No one ever says, hey, we subtract tax, we add it. So you got $59.95, and you got a sales tax of 8.875, and you're looking for the total cost right there. But again, you'll see that a lot of these problems, even though they have different names or scenarios or whatever the case may be, you'll find out that they're very related. They're very similar to one another. So again, your base price, right, is 100%. Let me write that in purple. It's 100%. Why? Because whatever dinner you had for $59.95, that's the base of your dinner, base costs. And then now, since this is an addition sign that I added, you imagine this as a large addition subtraction problem. So what's 100 plus 8.875%? Well, it's 108.875. And then now you can put this in proportion. How? Remember, you need numbers, you need 4 numbers, and they all have to have neighbors. So you need, again, these two and these two, and you're not using the middle. So it goes 595 over x equals 100 over 108.875. 8.875, yeah. And then you just cross multiply, right? 100x equals this number. Whip out your calculator to do this. 595 times 108.875 should have gotten 652,705. 625, and then you divide both sides by 100 here. And to divide by 100 means to move the decimal place left twice. So your total bill would be, and you always have to round, right? Round to the nearest hundredth or to the nearest cent. So it's $65.27. $65.27. You can see that you can check the number next to the 7. It's not a 5 or higher, so it doesn't round up. So this is just a regular price right there. Okay, so that's sales tax. Now commission is the same exact thing. It's just that instead of calling it sales tax, you just call it commission. So if I did example 4 the same way and said example 4, and we'll call this a commission. Oh, let's say You sold a $2.5 billion home, and your take is a 20% commission. How much money did you make? Now this one will be different because using the same box, but we're going to be using the information a little bit differently. So let me show what I'm talking about. Still $sign on the left or right, and then percentage here on the right or left, depending on how you're looking at this. So this we got to be careful. Okay. What are the pieces of information? You got a $2.5 billion home. You made a 20% commission. And they want to know how much money did you make. All right. So you got old, you got some kind of change, and then you got some kind of new price here. Again, the change is either a plus or a minus. All right. So sometimes you find out that the proportion, what you solve for, isn't the one directly related to the question that's being asked of you. So I'll say that one more time. Sometimes, like the first three examples, the proportion you solve for, it gives you the answer that you want immediately after you solve for x. Sometimes it does not. You might have to solve a proportion, but it's not the proportion you need, and then you refer back to this box so that you can find the correct amount of information. So let's write down what we do know. $2.5 billion home, right? So that's 2, let me use a different color here. So 2, 500, 000, that's 2.5 million there. It's now 2.5 billion right there. All right. And then the base cost is 100%. You know that you made 20% commission, so that's a positive change. So that means whoever you sold it to, they bought it for a total of 120% there. All right. Now, what about the rest of this, right? Well, it depends, right? Some students, if they put, I'm going to put the X in green here. Notice how the numbers that I used were in light blue. 2.5 billion, 20%. And then I didn't put a variable immediately for how much money did you make, and this is why. And notice that the percentages in purple, again, that came from the fact that we did the last three problems and we realized that this is an addition problem, so 100% is always the base, and then you add it, you get 120. Now this is the part where you're careful. If I put the x here, when I solve this proportion, I'll get the answer I want immediately. So let me write that really quick right here. If x is placed here, solving the proportion gives the immediate answer. That's very important to know, and I'll tell you why. Because if you then, let's use a different color here. Say for whatever reason you put the x down here. No, I want to use a different color. Say you put the x down here. No, let's not. let's call it y. Say you solve for the y down here, then if x is placed here, if y is placed here, the number solved for is correct, but does not answer the question. And why is that? Well, think about it. If you solve for x, x is the neighbor of this 20%. And the question's asking, what's my commission? So 20% of whatever's associated, in this case, 20% will be of 2.5 billion. Its associated cost will be this x. If we solve for y, we find out that we solve for the cost of the home after the 20% commission. So again, that would be a correct number, but it's not the answer that we're looking for. And you find that answer by subtracting from the original. So you might go, what do you mean by that? Let me take a moment to solve this. I'll show you both proportions. So here is the first proportion based on the green here. So we got 2, 500, 0, 000, and one more zeros. Okay, we're under x. This is going to give us the direct answer. And I'm color coding everything so people can see clearly. 20%. All right, so now if you solve this, this is going to give you an answer. And I'm going to go straight for the answer here so you can do the math yourself. But I'm going to just get the answer immediately. Times 20 divided by 100. So this gives you a $500 million commission. Not bad for a day's work. Now what happens if you do the same exact thing, but now do the proportion as I suggested right here? Because remember, you're supposed to know where the variable goes, but say you don't. Say you are setting it up and you're rushing it and you get the wrong number. And what I'm going to tell you is that it's not completely wrong, it's just that you have to know what's going on. So you can see 100% because it's, again, 2.5 billion associated with 100%, but now since you're putting a y, you get 120%. So what does y equal? Y equals now, after doing the calculation in proportion, right? I got it by cross multiplying. So it's now times 120 divided by 100. So this actually is equal to 3 billion. So obviously your answer isn't 3 billion in terms of 20% commission. That's how much the whole home cost after the commission. So my reasoning for showing this to you is that sometimes students put the variable in the wrong spot, right? X, you can see, is the correct answer. It gives you the immediate answer, as I wrote in the green. But if you use the y, or you put your x where the y is, it does give you the correct answer, right? This answer does not answer the question that's being asked. However, if you substitute this back into y here, you can see that if you take the new price and you subtract the old price, you get the difference between them, or the change. And that ends up giving you the same answer anyway. So you can see that if you take the time to pick out the correct variable in terms of its placement, you can get the answer correct 100% of the time. And if you don't, again, it's not the worst thing in the world. It just realizes that you have to realize that this box is cohesive. It's all in one. If you solve for another piece of it, it doesn't go to waste because it helps you find something else. In this case, if you found the new price by accident, you got 3 million, right? It's not your answer. You didn't make a $3 million commission off of a 2.5 or 3 billion commission off of a 2.5 billion home. You made 20% commission. So then you realize, oh, if I put the 3 million where the new price is, see how it's color coded, and you subtract it from the old price, then you get your change, aka your commission, which was this answer all along in the green box, or in the orange box, but written in green here. All right, so that's how you know, or that's how you can sense this box is supposed to evolve in terms of helping you figure out other pieces of information, even though you may not be able to. Because from the last couple examples, the three, right, we saw that we could have filled out the middle box, but we didn't have to. In this case, because the question was asked a little bit differently, you can see that it has a couple of other things that change. All right, so this one was, what is this, commission right there. Okay, that leaves us with discount markup and simple interest. Okay, so a discount is the same thing as a percent decrease. So I'll still do an example here so you can have it on record, but I'm going to say it right now. Example 5. Yeah, example 5. Call this a discount. However, discount problems are the same as percentage decreasing, decrease. The difference is that the percentage sometimes may be the answer, and sometimes they're asking for a dollar discount. So the other time was that I asked for a percentage discount, and then I told you what was the new price. Well, this time we'll do it differently. We'll say, suppose a coat was originally priced at $199. You bought it on sale for, let's say, I don't know, $50. What was the percent discount? So same thing, got our box. $, percentage, old change, plus or negative change, and then new. So this one's different because now I'm asking for a percentage. We haven't seen that yet. So we got originally priced at $199, bought it on sale for $50, and then they're asking for what's the percent discount. Well, you know it's already a discount, so you know it's minus, and you're looking for this number right here. What about the rest of the stuff? Well, if it was originally priced at $199 and you bought it for $50, what was the dollar change? Remember, this is a big addition or subtraction sign, or addition and subtraction problem. Well, what's $199 minus 50? Well, you had a change of $149. So you can see here that we have 4 pieces of information, but not everyone has a neighbor. What I mean by that is, remember these two we're going to use. Those are neighbors. But you can see that 50% or $50 doesn't have a percentage and $199 doesn't have a percentage, right? Well, it turns out that, remember, you can always put 100 here when it's the base cost. Remember, 199 was the base cost of it. So now we have our proportion using this and this. So that means we actually don't need this one right here. So now you're left with 199 for 149 equals 100 over x. Cross multiply 199x equals right here, 149 plus 2 zeros. Divide both sides by 199. And x equals what? 4900 divided by 199. So you get a really long answer, 7.87437, so on. But remember, we always round to 2 decimal places, normally with percentages. So our answer turns out to be x equals 74.87%. So that was the percent discount, right? Or they could easily ask you as well, how much of the original did you pay, right? If the question, here's a nice little follow-up here. I'll type it out here. If follow-up, if this is the percent discount, what was the percent paid of the original? And hopefully you realize that you can use this box, right? If you plug in 74.87 into x, which is right here, right? That's your answer now. How do you figure out what percentage you pay? Well, it's this empty box right here. But do we have to put a whole proportion and do this all over again? No, you don't, right? You just subtract. Why do I know you have to subtract? Well, because the fact that it's not only a discount, the fact that the change here is telling you that it's a subtraction problem. So you take 100 minus 74.87, you'll get the percent discount, or no, the percent paid. So 100% minus 74.87%. Percent paid is whatever this difference is. So this is the percent paid. Let me do this really quick. 100 minus 74.87. So you paid a little bit over 25%. Now the question is not going to ask that per se, but again, you can refer back to this box to dictate the information you need, given that you didn't make any mistakes, obviously. But yeah. All right. So this gives us now 2 other problems that we have to do. This is example 5. We have example 6. This is a markup. And you'll find out that a lot of these problems, they involve retail-based things. So you sell a pair of shoes that you got originally for $100, but you want to mark up the pair by 69%. How much will you advertise the pair of shoes? So you can see here, this is like anyone that, say, they're leasing or subletting their room and they want to mark up to make money. This is the same philosophy, and of course it applies to retail situations, because you find out that, as you always hear, at cost is what you paid for it. You know, I'll buy it at cost, I'll sell it at cost. That means you don't make a profit. But if you mark up from what you bought it for, then that's how you make your profit. So here, same box, percentage, $, old change, plus or minus, and then new. And then we have the information here, right? Oh, this is a typo here though, that you originally got for $100. So this is supposed to be dollars there. $100. I said dollars, but I typed in. So there's $100. You want to mark it up by 69%, and then it's like, how much will you advertise it for? So the original price is 100, and you want to mark it up by 69%, $100. And we'll mark it up by 69%. So then you're looking for this new price. Well, this one's relatively easy because of the numbers I use. However, we'll still use the box appropriately. So again, if it's $100, it's 100%, right? And then if you're going to mark them up, you're doing an add, it becomes 169%. So then the two proportions you're using are these. So then you have $100 over X dollars, 100% for 169. And you cross multiply, right? You have 100x equals 169.00. You divide both sides by 100, and yeah, you get the same answer, but you realize that now you're talking about dollars, $169. Okay? And that's pretty much it for the proportions. Now, the last topic is the simple interest that you're supposed to use. I'm just going to introduce what it is here, and then we'll do problems together at another date. So the formula for simple interest, which does not necessarily use the box method, is the following. Simple interest, I'll italicize here so that you know we're talking about a new definition here. So what is it? Simple interest is the following. I equals PRT, where what? I equals simple interest. This is always a dollar amount. So when people talk about simple interest, it means that they're talking about some kind of dollar amount, whether it's money owed or money earned. The P is the principal. Again, this is a dollar amount, but another way to think of this is your starting balance. R is the simple interest rate. It's important to have the word rate here because then you know you're talking about a percentage. Simple interest rate. Rate is key there. And then again, this is a percentage, but we must convert to decimal. And last but not least, T. T is time, but the trick about time is that must always be expressed in years. So an example of that, I'll write it here, is that if I gave you, oh, you invested for, say, 10 years and 6 months, right? So that's 10 years, 6 months, 10 and a half years. The number you would use is that t would equals 10.5, all right? So I just wanted to introduce the simple interest right here, which is the last part of the percentages chapter, and it doesn't necessarily use the boxes I stated up there. It looks more like a linear equation, right? I equals PRT, where if I give you 3 out of the 4 informations, you should be able to solve for the last variable, all right? And that wraps up chapter 6, and then we'll do some review, and you'll have homeworks assigned based on this. And then, of course, we'll go over anything that needs clarification in class as per usual, all right? Thank you very much.